Hi, my name is Elijah Hobbs. This lab was about observing how magnets fall down metallic tubes and the interesting reactions caused by Faraday's law. The primary physics principle we are using is Faraday's law, which relates the change of magnetic flux to voltage, which will allow us to analyze why magnets fall slower when dropped down metal tubes. This will also allow us to create a simulation of magnets falling through a tube in VPython. To properly model this experiment, we will need to use Faraday's law, the equation for the magnetic fields of a permanent magnet, the equation for magnetic force, V equals IR, the force of gravity equals mg, Newton's third law, and the equation for magnetic flux. First, you need to use the equation for the magnetic field of a permanent magnet to find the magnetic field created by the falling magnet. Then you need to find the flux of that field using the equation for magnetic flux and the area of the tube. Then you will need to use Faraday's law to relate that flux to the EMF being generated in the tube. Next, you will use V equals IR to find the current within the tube. Then you will use the current of the loop along with the formula for magnetic force to find the force the magnet is applying on the ring of current, which, when using Newton's third law, will allow us to calculate the force that the ring is applying on the magnet. Finally, you can use that force along with the equation for the force of gravity to find the net force that is on the magnet. For the experiment, we dropped the magnet down the tube 5 times and took a video of that process, and then went frame by frame in the video to determine the time it took for the magnet to fall through the tube, and then found the average amount of time that it took the magnet to fall down the tube. For my code, first I input the physical parameters from my experiment. Next, I entered in the appropriate mass and μmag values for the bar magnet. Then I copied my function for dipole B from lab 3. Next, I created a function to calculate d flux over dt. Then I fixed the code that calculates the current of the rings. After that, I calculated the force applied on the rings by the magnet. Then I calculated the force of gravity and used that to get the net force. Finally, I fixed the code to update the magnet's position and velocity, and my code to get my final simulation. If the resistivity of the conductor was reduced as close to zero as possible, then the magnet would almost entirely stop moving through the tube, since the low resistivity would mean that an extreme amount of current would be passing through the tube, generating a very strong magnetic force opposing the motion of the magnet down the tube. Cutting holes into the tube would decrease the magnetic force applied to the magnet, since there would be no continuous rings of current where the cutouts would be, which would not be able to generate a magnetic force on the falling magnet. This would cause the magnet to fall faster through the tube, since there are less continuous rings of current exerting force on it. A big source of error in my lab was that the magnet we were supposed to use to fall down the tube was very chipped, so it would always fall sideways and touch the wall as it fell. This caused it to fall a lot slower than normal, since the friction with the wall is contributing to the opposing gravity instead of just the magnetic force opposing gravity. Overall, this lab is super cool and a very interesting application of Faraday's law.